Alright, now let's talk about something that's not quite a mirror. We'll think about a surface that's not all bumpy and curvy and everything. It can be fairly flat, but it's not flat under a microscope. If we look at it under a microscope or a very powerful magnification device, we'll see that instead of being completely flat, instead has little bumps and ridges in it. So if we draw a diagram, it might look something like this. We can see that the surface of this piece of paper, say, is not completely flat. In this case, the light rays that reflect from this surface aren't all parallel once they reflect, because they reflect off the surface in a different way for each part of the light ray. And this means that instead of getting parallel lines, we get lines pointing in all different directions, which can be seen from all different directions, as opposed to only one direction. This is called diffuse reflection. In contrast, if we have parallel lines being reflected into parallel lines, we call it specular reflection. We have diffuse reflection and specular reflection. Now, for almost everything, we can see diffuse reflections rather. Although if we could only see in short wavelengths or large wavelengths, the world would look very different. If we have very long wavelength waves, like radio waves, then they tend to do a lot of specular reflection instead of having diffuse reflection. And very short wavelength waves do the opposite thing. Almost all the objects that we can see in the real world have diffuse reflection rather than specular reflection. Take a look at this picture of a keyboard, for example. We can see that right in the middle of the spacebar there's a bit of specular reflection because we can see that there must be a light illuminating the keyboard. The thing is, we can see the rest of the keyboard illuminated by this light even though the keys aren't directly reflecting that light. The light is lighting up the entire keyboard due to diffuse reflection. And of course, this is why we can still see the keyboard even if it's not being directly lit up by the light source. If, for example, we were to look at a mirror in a dark room, we could only see the reflection of something if it was a bright light, but we wouldn't be able to see the rest of the mirror. So you can imagine that if you hold a torch in a dark room and shine it at a mirror, you'll be able to see the reflection of the torch, but no other part of the mirror. That's an example of specular reflection. Specular reflection isn't very good at illumination. Diffuse reflection, though, as we can see, lets us see objects even if they're not being lit up directly. Explain the difference between a mirror and a piece of paper in terms of light reflection. Now we know that if we hold up a piece of paper, we don't see our own reflection in it. So they have to differ somehow. The difference between them, of course, is the difference between specular reflection and diffuse reflection. When light reflects off a mirror, parallel beams of light always reflect in the same direction because the mirror is perfectly flat and smooth. A piece of paper is not microscopically smooth. It's actually a little bit rough. It has these little up and down ridges. What this means is that it does not produce specular reflection. Instead, the light undergoes diffuse reflection. So parallel beams of light bounce off the paper in different directions. It means that if a piece of paper is being illuminated by a source of light, you don't need to be standing directly in the reflection to be able to see the light. The reflection of the light source bounces off in all directions, which means that we can see the piece of paper from any direction if it's being lit up. Whereas for a mirror, we cannot see the reflection of a light source from every single location around the mirror.